Electricity. Electricity is energy created by moving charged particles. Here we have a negatively charged atom, and here we have a positively charged atom. If you remember from school, the first element in the periodic table is hydrogen. Its atomic number is 1, which relates to the number of protons, positively charged particles, in a nucleus. Surrounding it is an electron, a negatively charged particle. If we look at lithium, we can see that there's one free spare electron in its outermost shell. Copper also has one free spare electron in its outermost shell. And gold also has a free spare electron in its outermost shell. It's these spare electrons which can be used to conduct electricity. Electricity is energy created by moving charged particles. Around 600 years before Christ, in Greece, a mathematician named Thales discovered that amber rubbed with animal fur attracted light objects. This is static electricity. It may also be produced by a mix of chemicals in a cell or battery of cells, or by moving a wire in a magnetic field in a generator. It may also arise electrostatically. An electric current is a flow of charge. Current is measured in amperes and charge in coulombs, such that 1 coulomb is the charge passing a point in a circuit when 1 ampere flows for 1 second. Electricity flows in a circuit with the flow of electrons from negative to positive. Electric current means a flow of electric charge, or the rate of flow of electric charge. This flowing electric charge is typically carried by moving electrons in a conductor such as a wire. Solutions are made up of dissolved ions, which can carry the electrical charge and transmit current. These solutions are known as electrolytes. The SI unit for measuring the rate of flow of electric charge is the ampere. A solid conductive metal contains free electrons. These electrons are bound to the metal lattice, but not to any individual atom. These electrons move about randomly due to thermal energy, but on average, there is zero net current within the metal. When a metal wire is subjected to an electric force applied on its opposite ends, the free electrons rush in the direction of the force, forming what we call an electric current. The 2 terminals of a DC voltage source, such as a battery, place an electric field across the conductor. The moment contact is made, the free electrons of the conductor are forced to drift towards the positive terminal. The free electrons are therefore the current carrier in a typical solid conductor. For an electric current of 1 ampere, 1 coulomb of electric charge, which consists of about 6 million approximately, elementary charges, drifts every second through any plane through which the conductor passes. Conventional current. To provide a definition of current that is independent of the type of charge carriers flowing, conventional current is defined as a flow in the same direction as a positive charge. So in metals where the charge carriers, electrons, are negative, conventional current by definition flows in the opposite direction to the electrons. In the diagram, the free electrons are attracted to the positive electrode, whereas conventional current flow is in the opposite direction. Electrodes. An anode is an electrode through which electric current flows into a polarized electrical device. The direction of electric current is, by convention, opposite to the direction of electron flow. In other words, electrons flow from the anode into, for example, an electrical circuit. The mnemonic, acid, anode current into a device, is a useful way of remembering this. The anode is positive in a device that consumes power, and the anode is negative in a device that provides power. The diagram is half of a lead-acid battery. Lead solid dissolves into solution, forming positive lead ions, and releases free electrons in so doing. This is a diagram of a lead-acid battery. Lead reacts with sulfate ions to form lead sulfate. Lead supplies 2 positive charges and the electrode becomes negative. Lead dioxide reacts with sulfuric acid to form lead sulfate, supplying electrons, becoming positive.